Right now, deep inside your skull, your hippocampus is actively deleting memories, deciding which ones you keep forever and which ones vanish. And the neuroscientists who map this process admit they cannot stop it, not slow it, not redirect it. The part of your brain that was supposed to be your memories filing system has a second function nobody told you about. It doesn't just store, it purges. And it is doing it right now. You think forgetting is a failure, a glitch in the system. Something that happens to you when you're tired, distracted, or getting older. That's not what the science says. What the science says is that your brain is running a deliberate, aggressive forgetting protocol around the clock, and the memories it's targeting are not the ones you'd choose to lose. The conversation you had this morning, the name you heard twice yesterday, the thing you told yourself you'd remember later. Your hippocampus flagged those as low priority. It is erasing them as you read this. And the terrifying part, the decision was made before you even realized you were forgetting. Here's what's actually happening inside your skull. Your hippocampus, your memories filing system, replays every experience you had that day in compressed, accelerated bursts during sleep. While you're unconscious, it runs through your day at 10 times the speed, and for each memory it encounters, it makes a binary call, consolidate or suppress. The ones it suppresses don't fade slowly. They get actively inhibited. Your prefrontal cortex sends a suppression signal that physically quiets the hippocampal neurons holding that memory. Not neglect. Inhibition. The difference matters. Neglect means the memory could return with the right cue. Suppression means the pathway is being intentionally muted, like a noise-canceling signal applied directly to a specific thought. And this process scales with stress. The higher your cortisol when the memory formed, the more aggressively your brain tries to decide its fate overnight. What you experienced under pressure is the most vulnerable. Your brain treats emotional intensity as a reason to intervene harder, not a reason to protect the memory more carefully. Memory researchers mapped this suppression circuit and then spent years trying to find a way to block it. They failed. The mechanism is so deeply embedded in how the hippocampus consolidates information that interfering with the suppression breaks the entire system. The forgetting is structural. Without it, every detail of every day would compete for retrieval at equal volume. The forgetting is what makes the important memories loud. But here's the part they don't publish in the summaries, and we're getting to exactly how this changes what you should do. The system is not optimized for your goals. It's optimized for survival. It prioritizes threat-relevant and emotionally charged content. What you deliberately studied, what you intentionally tried to remember, that carries no special flag. The hippocampus doesn't know you cared. It only knows what your nervous system signaled at the moment of encoding. And we'll get to the specific window when high performers override that entirely. Now here's where the common advice breaks down. This is the part that will feel counterintuitive. You've been told to review information before sleep. Read your notes. Rehearse what you want to remember. That's backward for a significant percentage of people. If you rehearse material right before sleep, you're flagging it as emotionally active, and you're handing it directly to the suppression decision window at its most volatile moment. Bedtime review spikes cortisol just enough to put the memory in the high-intervention zone without embedding it deeply enough to survive the night. Meditation before reviewing can actually make this worse, not better, because it lowers arousal thresholds and makes the brain hypersensitive to what it encounters immediately after. The calm you created becomes the lens that makes your reviewed material feel threatening by contrast. More people have lost memories to pre-sleep review than to sleep deprivation. That part nobody publishes. Here's what high performers actually do. This is the rule. They don't review before sleep. They review at the end of the first alert window after waking, typically 90 minutes post-waking, when cortisol has peaked and begun to descend, and the prefrontal cortex is running full suppression override capacity. That's the window where your brain's executive control is actively counteracting the hippocampus's automatic culling. During that window, deliberate rehearsal carries a different neural tag. It gets marked as intentional, effortful retrieval rather than passive re-encoding. The hippocampus responds differently to effortful retrieval. It treats it as a survival signal. If you had to work to remember something, the brain registers that effort as importance. This is why high performers who seem to have extraordinary memories are not memorizing more. They are timing their review to land inside the anti-suppression window. The rule isn't what to remember. It's when your brain will agree to keep it. Tonight, don't review anything. Let the consolidation run uninterrupted. Tomorrow morning, 90 minutes after waking, before your phone, before the second cortisol spike from decisions and notifications, open what you want to remember and force recall. Don't reread. Retrieve first. Close the material and work to remember before you look. The effort is the signal. That's the whole rule. But the hippocampus isn't running this gate alone. There's another region, sitting even deeper, that isn't suppressing memories after the fact. It's deciding at the moment of experience whether a memory gets a chance to form at all. And the criteria it uses to open that gate have nothing to do with how much you cared about the moment. They have to do with something far more specific and far more invisible.